Hello, this is Chad Martin. Today I'm going to be looking at a topic for the CIS 260 database management course. I'd like to take a look at database normalization. And although that may sound completely foreign or perhaps even daunting, especially for those of you who haven't worked much with databases in general, or for those who may have heard of the term database normalization but aren't quite sure what it means or why it might be of importance, I'm hoping that we'll be able to break it down enough to begin making sense of it. And for those of you who might already be quite familiar with the topic of database normalization, please use this as a refresher, or even better, maybe you'll hear something that you weren't aware of and you'll be able to use that knowledge elsewhere. So, what is database normalization? Well, in its very simplest form, it's the process of organizing data in a database. And from that basic definition, you might already be thinking, oh, well, I've created a database before and built some tables and even created an application that utilized that database. And since it all seemed to work quite well, I'm guessing I've already got this whole database normalization thing down pat. Well, maybe, but I'm guessing maybe not. It does indeed include most of those things, but there's quite a bit more to it than that. It touches on things like table relationships and the rules to those relationships, which are put into place to make the data more flexible, but more importantly, to help better protect the data. It's also quite beneficial in helping us to eliminate data redundancy or repetitive data, and it helps us with keeping our dependencies more consistent. So, repetitive data or redundant data not only wastes space, but it can create other problems as well. For example, if we're storing employee addresses in more than one location, then a simple change to an employee's address needs to be accounted for in more than one location and needs to be stored and changed in the exact same way in more than one location. And this is just messy. And whenever it comes time to actually consume that particular data, where is it drawn from? Well, you might want to say something like, but I mean, if we're storing and changing those employee addresses consistently across all of those locations in the database, then why does it matter where we're drawing the data from? Couldn't we just pick one of those locations and call it good? And the answer is technically, yes, you could. I mean, without database normalization in place, you could obviously continue practicing several bad habits and avoid having to more proactively and carefully adopt sound database design. However, it certainly wouldn't be my recommendation. Another consideration with regards to database normalization is deciding how to keep data dependencies more consistent. For example, you probably wouldn't store customer purchase history in a product catalog. Yes, customers might use a product catalog to purchase products, but those things would be stored separately in completely separate tables. One rule of thumb that I try to apply when drafting a solid database layout is to always consider how easy or difficult it's going to be to consume that data from the database. How difficult will it be to generate a report of customer purchases? How difficult will it be to generate a file of employee addresses? How difficult will it be to determine real-time product availability for any given product? If we take the time to consider the structure of the database up front, then working with the data itself will be much more intuitive. Database normalization also helps us avoid the following anomalies. And if you're not familiar with the term anomaly, it's simply something that deviates from what is normal or what's expected. So let's look at these anomalies. There's the insertion anomaly, the update anomaly, and the deletion anomaly. To better explain these anomalies, let's say we have an employee table with the following fields, which looks something like this. It's got an employee ID, employee name, employee address, and employee department. Very simple. Let's also assume that the employee department field is required. Well, whenever a new employee is hired and in training and they've not yet been assigned to a department, we'd be unable to insert that employee into the employee table without either fabricating some sort of false department, or putting in something like in training into the employee department field, which means we'll have to visit that record again once they've been assigned to a department. This is referred to as an insertion anomaly. We've taken something as simple as inserting a record into a database and made it much more difficult than it needs to be. Next, let's look at what an update anomaly is. Using the same employee table for simplicity's sake, let's say that Jane Smith belongs to both the engineering department as well as the product development department. This means that Jane is going to have two records in the employee table. Now let's say that Jane changes her address. So now we're going to have to change her address for both of her employee records in the employee table. And if we accidentally only update one of those records with the correct address, then Jane's data now becomes inconsistent. The last anomaly to look at is the deletion anomaly. Again, given the same employee table as referenced previously, let's say that Jane's company decides to completely do away with their drafting department. If they remove any records from the employee table that reference that particular department, they'll end up removing the employee as well, removing the employee record from the database as well. And yes, I realize those particular examples all could have been handled differently, either through SQL or some sort of business logic. But my aim was simply to crudely demonstrate at a very high level what those anomalies mean. The more frequently you interact with actual data, you'll become more adept at seeing potential anomalies in both existing tables and tables that you are designing in your own applications. Explaining to your supervisor that you just deleted hundreds of employee records accidentally is really, really a bad way to start the day. So, the ability to recognize these anomalies um, is such a wonderful skill set to have. Okay, so we've talked very briefly about database normalization and looked into a few different anomalies, but how do we actually put this into practice? Well, fortunately for us, some very brilliant minds paved the way and came up with what are referred to as normal forms. And these normal forms are what we can use to minimize repetitive or redundant data, as well as helping us to improve the integrity of the data itself. I liken these normal forms to something like building a car. You start with a chassis or a frame, which you then build upon. Once you're able to actually get this car running, you might say, this thing doesn't seem very safe. So you start to build in various safety features, for example, seatbelts, airbags, mirrors, etc. From there, you might think, well, it sure does use a lot of fuel. So you begin to work on optimizing fuel intake, maybe reducing the overall weight of the car, possibly looking into fuel alternatives, etc. In essence, you're actually normalizing that car as you continually enhance its overall functionality. Let's take a bit of a deeper look into these normal forms and what they mean. So we start with 0NF or zero normal form, which is basically no database normalization on this table at all. So let's take a look. I'm going to share my screen here. And hopefully you can see here a table that is in zero normal form. Let's look at why this is in zero normal form. This refers to a table that contains repeating attributes. Let's take a look. This table is 0NF because it contains repeating attributes. If you'll look here, we have product ID, product name, product description, product location, and then look at these three: product type 1, product type 2, product type 3. Since any given product could have one to many types, this would not be optimal. If a product has more types than we can accommodate, we run into a problem. And if we're no longer carrying a specific type of product, for instance, if the iPhone 6 no longer existed for some reason, then we end up with a record with types that are oddly populated. So we've got the product type 1 field here populated with an iPhone 5. The product type 2 field then would be populated with nothing, and product type 3 would be populated with 6S. Uh, I'm hoping you can just visually see that there's an issue here with the way this table is built. So how do we get past zero normal form? How do we get past 0 NF? Well, let's look at 1 NF. Okay. 1 NF refers to a table where there are no repeating groups or repeating fields, and attributes are uniquely named. So let's take a look. This table is 1 NF because it contains no repeating groups. If you look here at our original table in 0 normal form, we had product type 1, type 2, type 3. Well, now we've created a product type table, and that just uses the primary key from that product type table to store our product types. So now our iPhone references product type 1, which is a 5, an iPhone 5. Our iPhone also references product type 2, which is an iPhone 6, and product 3, which is a 6S, etc. With this small change, we're now able to more logically add a new type for a product and/or remove one without issue. Hopefully you can kind of see the benefits of just that small change. So how do we get past 1 NF? Well, let's take a look at 2 NF. Now 2 NF refers to a table where we eliminate redundant data. If you look at our table in first normal form, what you notice is our product table has the iPhone in here 3 times. And that was to accommodate the fact that the iPhone had 3 different product types. Well, if we look at 2NF, what we see here is we no longer have repeating iPhone records in the product table. We've got one iPhone record, and we were able to accomplish this by adding a what's kind of referred to as a crosswalk table. So we've got a product type table, which now ties our products to our types. And that allowed us to eliminate completely the repetitive iPhone records and the repetitive in-table record. Much cleaner. Hopefully you can see that that's just much cleaner. This table is 2NF because we've successfully removed the repetitive data from the previous product table and created a new product type table to relate the old product and type tables. Okay. So how do we get past 2NF? Well, let's look at 3NF. Now, 3NF refers to eliminating what's known as transitive dependencies. And one thing I might point out, in order to get to 2NF, you have to satisfy 1NF. In order to get to 3NF, you have to have satisfied 2NF and by default 1NF. I failed to clarify that earlier, but these normal forms have to have satisfied their predecessor in order to even move on to the next normal form. So now we can look at 3NF. Okay, so what have we done here with 3NF that was different than 2NF? Well, if you look here, you see a product location field. That product location field actually causes us a little bit of trouble. It's a transitive dependencies. A transitive dependency exists whenever a non-primary field, non-primary product location, non-primary field, whenever a non-primary field references another non-primary field. This table is 3NF because we've successfully removed the transitive dependency from the previous model. And now we have a new primary key, product location ID. And this references the primary key of the new product location table. Much more elegant solution. And finally, I put together a diagram real quick for those that maybe are more visual, hoping this might help a little bit to show where we were and where we are now. So we started with 0NF, a product table, repetitive attributes, and now we've got this beautiful model. And although the final model in 3NF may look busier or more cumbersome to work with than the original, it's leaps and bounds more elegant to work with. Data flow in and out of our new model is actually simplified many times over. If we need to add a new warehouse location to store our merchandise in, we simply insert a record into the product location table, which doesn't interfere with anything else. So we've actually done quite a bit. We've moved a table from zero normal form through first normal form into second and into third. I mean, it's pretty amazing, and it really didn't take us that long. Well, I hope you've been able to learn something new from this lesson, and I really, really, really sincerely hope you enjoy the rest of your day. Thank you.